following uncut footage is of a high-volume axial solder dipping machine built by Robotic Process Systems in Liberty Lake, Washington. The system featured several feeding mechanisms, including a bowl feed to a hopper mechanism and a Ferris wheel escapement. The Ferris wheel deposited components on the indexing chain, which fed approximately 100 components out to the gripper. This operation happened simultaneously to the process operations in the balance of the machine, and was designed in this fashion to keep a continuous flow of product through the machine. As the product indexed through the machine, it first saw a hot acid bath for pre-cleaning operations, with an air knife blow-off, and then moved into deionized rinse, and then into a drying tunnel. All of this is in preparation for the fluxing and solder dipping operations. The machine was set up to handle from 1/8 watt up to 1/4 watt sized devices, although the machine was set up specifically for handling diodes in this family size. Continuing down the machine, after the final drying station, one of two robotic arms with 24-inch long grippers would grip 100 parts simultaneously by one of the lead ends. What we're looking at now is one of those robotic arms. It's actually an XZ operation in robotic terms, where there are two axes of movement, which is vertical and horizontal, picking components up from the chain, moving them first to a leveling station where all the devices are leveled relative to the surface of the flux and the solder, then moved to the fluxing operation, and finally to the soldering operation in the dynamic flat wave solder pot, which features nitrogen inerting. With the first side complete, the product was replaced back on the indexing chain, where it was then moved through a rinsing station and a second drying tunnel in preparation for being picked up by another robot, which then solder dipped the opposing side. All of the appropriate plumbing, including flux density control, deionized water recirculation, and all of the electronic controls for the operation of the machine, with the exception of the host controller, were stationed underneath the superstructure. All functions of the machine, including turning on and off the deionized water at the individual stations, the blowers, the transport mechanism, all interlocked through a 486 PC remotely mounted in its own control console. This section of the video shows the machine in its final form just prior to ship. Components are being picked off of the load station and onto the transfer in preparation for indexing through the machine. The cycle time is dependent upon the soak in the longest station. The machine, when set up at our customer's site, was set up for a 20-second soak in the acid pre-clean. This allowed adequate time for body leveling, fluxing, and solder dipping. However, a double solder dip operation took an additional 10 seconds, allowing the index time of 30 seconds per cycle. Each index moves 100 devices through the machine. Here we see the pickup, the leveling, fluxing, and into the solder dip operation. As the machine was finally installed, all of the movements just witnessed were expedited considerably, saving over 50% of the total productivity at this station. The machine would consistently produce between 12 and 15,000 units per hour. The offload of the system is to a oscillating hopper. Optionally, RPS could fit a tape and reel system. The final dipping operation is being witnessed, and at this point the devices are put on a second chain which feeds back to the operator through a final rinse and dry station. The product coming off the opposing end was completely dry, fully processed, ready for tape and reel or additional operations.